Almost a year ago, around March 2023, when ChatGPT just came out and became the hottest topic in the world, I remember clearly seeing a demo from Aaron where he built an interview breaker, the ChatGPT tool that helps you crack the job interview.
This week I built something called the Interview Breaker, a proof of concept made with ChatGPT for cracking job interviews. It takes your previous experience, listens in on your conversation with your interviewer, and tells you what to say, fills you in on things you might not know.
How do you decide what to prioritize when architecting a back-end service?
As a senior architect, I prioritize the scalability.
What sort of tool is going to wreak havoc on the job interview process? Usually when these big technologies emerge, like computers or the internet, it changes all of the processes that emerged before it. That means some of these questions might not make sense to ask anymore if we're looking very far into the future.
I thought that was a fantastic idea because back then I was actually going through some job interview process. So I would love to have real-time tool can actually help me crack it. And I actually did try to build that prototype where it used speech-to-text model to generate the transcript and also use large language model to generate answer. But that prototype never worked well in real life because one of the hard requirements for those real-time interview or conversation co-pilot is that it has to be low latency and real-time. If it would take 30, 40 seconds for it to actually generate some results, it's not going to really work. Unfortunately, that was the case back March last year. Both speech-text model and large language model took quite a long time to inference. So this was a simple project in theory, but very hard to build a usable product in reality. But a couple months later, I saw another product showcasing a similar scenario, but with almost close to real-time performance.
In aerospace engineering, such as in jet engines or spacecraft re-entry, how do you approach these challenges?
Let me think about it. In aerospace engineering, selecting materials for high temperature application. So first, I'll approach the challenges in temperature resistance. So one of the main challenge is to find a material that can withstand extreme temperature in high temperature applications, right? So I'll prioritize those materials that have like high melting points and can maintain their structural integrity at elevated temperatures. There's another challenge I have concern is the heat transfer management. I will select the materials, have good thermal conductivity to efficiently transfer heat away from the critical components.
So this guy cracked an interview about aerospace engineer with zero experience of aerospace. Well, that is definitely not the future or product I want to drive to get unqualified people for a job. I do think a real-time conversation co-pilot that can listen to the conversation and give any feedback or suggestion in real time can add a lot of value to help people to create higher quality conversation. For example, my background is a product designer, and one of the most important skills is user interview. But the ability to conduct user interviews successfully is not easy. Even after years in the industry, I'm still learning and practicing because you need to juggle between taking notes, asking the right question, and review what has been talked about so far to decide which area you should dive deeper into that can uncover more insights. And I remember clearly when I just started the career, it was extremely helpful to have a senior researcher in the room who can jump in and ask some follow-up questions that I haven't really covered. So having a real-time conversation co-pilot is almost like having a senior UX researcher always with you on the call. And on the other side, for job interview example, is not only useful for just interviewee, it's also useful for interviewer as well. Because I also remember back then when I just started hiring people, it was actually quite nervous for me as an interviewer for the first few job interviews because I never went through any proper hiring training. So I also kind of didn't know what kind of question I should ask to really understand whether interviewee is a good fit. With the power of AI, I can totally see that we can just load some context information about what type of talents do we want, as well as interviewee's resume into the large language model so that it can listen to the conversation and propose follow-up questions that interviewers should ask to help them better understand the interviewees. And lastly, I believe it can also be quite useful for in social conversations because I am a pretty introverted person. Sometimes I can be a little bit socially awkward when I need to have a conversation with someone who I'm not very familiar with. So in general, I really believe in this real-time conversation co-pilot idea. So I decided to give it a try. And thanks to some new model just released recently, I was able to quickly build a web and mobile app that can listen to the conversation, generate transcript in almost real time with no latency, and generate conversation suggestions and answers instantly. What's cool about it is actually not hard to build, and you can take part of this demo and build your own real-time voice applications. I'm going to take you through step by step how can you build it. So let's get it. So there are two key components to build a real-time conversation copilot. One is real-time transcript and second is fast inference. So firstly, the real-time transcript. This is one of the biggest challenges to build such a real-time conversation companion because you want it to be fast. And normally for common speech-to-text model like Whisper don't have streaming ability out of box, which means typically it is designed for scenario where you already have the whole conversation recorded and then you send to speech-to-text model for you to get a full transcript back. But obviously this is not what we want because otherwise it will probably take 30 seconds to even 1 minute to generate transcript even before we're hitting the large language model. One of the most popular solutions is instead of waiting for the whole conversation to finish, we actually create a recurring loop that continuously captures small audio chunk like every 2 to 5 seconds. Send it to speech-to-text model, generate a transcript, and in the end, we stitch together all the small chunks together. And by doing this, you can almost get real-time transcription capability. And this might sound simple, but there are a lot of caveats to actually make it accurate and working well. For example, if I have a sentence called I have just cooked fried chicken tonight with beer from bottle shop, it might make sense if you have the audio file of the whole sentence. But when you break it down, then each audio clip doesn't mean too much because the word just got cut off in the middle. And if you just simply stitch them together, probably will get an inaccurate answer. So there are lots of optimizations that can be done to have some additional processing. For example, get timestamp of each word so that we can compare and enhance between those connecting words. So I would say real-time transcript is probably one of the biggest challenges in terms of implementing such solution. But luckily, the speech-to-text model has evolved a lot for the past few months. And there are a lot of solutions we can actually choose from. For example, you can easily access some incredibly fast speech-to-text model on platforms like WhisperKit easily. And there are even new projects like WhisperKit. They allow you to deploy those real-time speech-to-text model on your mobile device like Apple Watch directly.
Gemini Advanced, this is Google's answer to ChatGPT Plus. How does it stand apart? How does it compare in your mind?
Well, Gemini Advanced has...
And I will show you how can you build a real-time transcript functionality with those technologies that I just introduced. But after that, we also have challenge number 2, which is we want really fast large language model inference, which means we actually want large language model to be able to look at transcript we have so far. It sometimes can be quite big and able to generate suggestions in very fast manner. And to achieve this result, there are quite a few different things you can do. The first and most important thing is that you got to choose a really fast large language model. So far, model like GPT-4 has been extremely powerful, but the time for GPT-4 to generate answer is actually quite long. For a scenario like this, I think small open source model are going to play a big role because firstly, those models like Mixtral 7B is a lot smaller than GPT-4, which means it is able to generate response faster with less computing resource. On the other hand, after you getting some real user data, you can actually use those data to train a small model. So those small specialized model will be able to help you generate response much faster with friction of cost. And there are even open source model like Moontrain, which is a multi-model model that is so small that can almost deploy on your mobile phone. And one of the biggest problems for those open source model is that not a lot of people actually have knowledge and understanding of how to optimize and deploy the model at scale. But with the emergence of platforms like WhisperKit, where they have those incredible open source model already hosted and fine-tuned, then the use of those open source model becomes a lot more easier. And it just provides so many more options for you to choose. And for the demo I'm building, I'm going to use a mixtral model, where I found it deliver incredible results with very fast speed. But apart from choosing a fast and small model to achieve really fast large language model inference, there are also a lot of optimization we can do. For example, reducing the input, because as the conversation gets longer and longer, it will take quite a while for large language model to input all the text. But there are methods that I mentioned in other videos like large language model lingua can be used here. So the way large language model lingua works is that they realize for scenario like interview, probably a lot of text here are actually noise that don't necessarily contribute to the results you want. And the way large language model lingua works is they use a super small model to identify those redundant words and only extract useful information out from the transcript. Then you can use it to send to the proper large language model to generate answer. So this is definitely one method we can try to improve speed here. And on the other hand, there are also things we can do to reduce input token by summarizing the transcript. So it is very similar to how we optimize memory for agents. At default, we probably just feed the whole transcript to large language model. The problem is that the number of tokens will just linearly grow with the length of conversation. And eventually, it will probably hit an arrow because it met the context window limit. And the way we solve this problem in building agents is that we will use something called conversation summary memory. That basically means instead of sending the whole transcript, we can summarize what has been talked about earlier. But for the, let's say, last 3 sentences, we will keep exactly what has been talked about word by word so that the large language model has full context about what has been talked about before, but also has a lot of details about recent conversations. And this summary process can be automatically triggered every 30 seconds. So this is definitely another method we can try to speed things up. And in the end, we should also try to use some prompt engineer method to really reduce the output token. So those are core methods that we can use to achieve this real-time transcript and also fast inference. I actually did a few iterations from initially just a web app I built and eventually a mobile app. And I'm going to quickly take you through how can you build those demos so that you can actually take the part that you want to build something else. So let's get it. So the first version I built is a web application, which looks something like this. At top, I can give some context about the conversation I'm having and what kind of suggestion and support I expect from this copilot. Then I can click on a button to start recording, which below here will show the transcript in real time. And then I can just click on the get suggestion button anytime during conversation. And then the copilot will basically read the whole transcript and generate a suggestion for the conversation. And we're going to build this web app using a framework called Flask. So this basically allows you to quickly build a web app using Python. And the way it works is that we will basically build a normal Python script in app.py. And then we will also create a folder called templates. Inside, you can put different HTML files that you can use to render the web page. And then we'll use WhisperKit to run both speech-to-text model as well as a large language model. And if you don't know what WhisperKit is, they're probably one of the most popular and easiest platform to use in terms of running and fine-tuning open source AI models. From image generation, large language model, video generation, and even music generation. So almost all of those latest AI models are available here. And I personally use WhisperKit a lot. And the main reason is that they really took away all the burdens and problems in terms of deploying open source model. Because everyone loves open source model, but most of us just want to run the model without worrying about how to deploy a model, how to fine tune the performance, how to deal with scale. And 2 models we're going to use today. One is this model called incredibly fast Whisper model. So this is the latest speech-to-text model. This is probably one of the fastest speech-to-text model that we can find. And it is already hosted on WhisperKit that we can use. And the other is mixtral instruction model. And the reason I want to use this model is because it is small, fast, and also high performance. For our specific use case, it can generate suggestion for a fairly long transcript within 3 seconds. So this is a good one for us to use. So firstly, we need to create an account on WhisperKit. And both of those models are actually free to use on WhisperKit unless your volume starts picking up. So firstly, let's create an account on WhisperKit so we can get an API endpoint. You can click on Get Start button. So I will sign with GitHub. And once I get it in, I will click on Explore button. This is where you can see all the models that are available on WhisperKit. In our case, I want to use Whisper. So I will type in Whisper here and select the model. And in this detail page, this is where we can try this model out. So for this speech-to-text model, I can try it out by uploading audio file. And they also provide example audio file for almost 1 minute. If we click on the Run button, on the right side, it starts running. And you can see for transcript roughly 1 minute audio, it only took 2.5 seconds. So this model is indeed really fast. And to use the model in our Python code is actually very straightforward. So there's the Python code tab. If I click on that, all we need to do is just install WhisperKit Python SDK, set the WhisperKit API endpoint, import the library into our Python code, and just call this model. That's pretty much it. And it is same thing for using mixtral as well. So let's get started. I'll open Visual Studio Code, which is where we're going to build this web app. And first thing I need to do is install WhisperKit. So I'll copy this, paste it in, pip install WhisperKit. Okay, great. And next thing we want to do is create app.py. This is where we will define all the functionalities. And meanwhile, we also need to create a folder called templates. And inside templates, we will create index.html. And this is the front end of the web app. So we will define the HTML page to display those results. But we'll come back to this later. Let's firstly open app.py, import a few different libraries that we're going to use. And for this project, we were also using AWS as a service to upload those temporary audio recordings. And if you don't have AWS, you can create a free account. You will see an interface like this. So AWS is not the most user-friendly platform out there. It's actually pretty confusing, but I will quickly show you how to do it. So you will click on S3, which is storage service that we're going to use. And you will click create bucket. So bucket basically means like a project. I can give it a name, conversation copilot. The rest you don't need to change, except you need to uncheck block all public access, acknowledge, and click create. So this should create a new bucket for you. And we'll click inside here, go to permission, and then we'll need to add a bucket policy. So think about this as a kind of permission setting. You can click on edit, and you will see this bucket ARN, which represents for resource number. You just copy that and click on policy generator, select S3 bucket policy, principal, type in the star sign, actions, choose all actions, and ARN, you just paste in the thing you just copied with add statement, generate policy. So this is the thing that you will need to copy and paste in here and save change. And that's pretty much it. The next, you will need to get this three information. Bucket name is basically the name you put in here. So I copy this, paste it in. Before access key and secret key, then you need to click on service button, go to IAM, click on users, go to your own user, and here you can create an access key. So I click on create access key, click on other, next, and give it a quick description, Jason, main. So here's you will get access key and the secret key. So that's pretty much it. You just need to copy over the access key and secret key, then you can start using this AWS. And next, we will create the Flex app and also create a replicate object called model. So this is pretty much the setup. We need to point this Python app to index.html so that it will know which HTML template it should look at for rendering the web page. And the way to set up in Flex, you basically do something like this, add app route /. So this basically means when this Flex app is running and when we open the default page, which is /, it will call this function. And this will actually return a function render templates using index.html. That's pretty much it. And the same thing you can just do for the function of transcript audio. So we're putting add app.route /process audio and method equal post. So this basically means we create a post API endpoint that you can call from index.html. In our case, I will create a function called process audio data. So we'll get audio chunk data first by doing this. So request of files audio basically means we'll look at the request body and then get the part called audio. Then we'll try to upload this audio file to AWS first, so that we can get a temporary file URL. And then we'll try to call replicate by doing model.route, point to the specific model that we want to use, as well as the list of inputs. And you can get this specific code snip by go to Whisper model page, click on Python, and below here, this code snip you can just copy and paste in. And here, the audio file, I'll point to the URL that we just upload temporary. You can define the language here as well. And then I'll print out output, get the actual result, and return it. So this function will basically take the audio chunk we have and send to replicate the Whisper model. And next, we want to create another function that will send the whole transcript to mixtral to generate some suggestions. Again, we'll do add app.route get suggestion method equal to post. The function will be named get suggestion. So I will firstly get a transcript, which is a full transcription Whisper generated, and also try to get a prompt text. And on the front end, we'll basically have input for users to type in, and it will be able to pass on to the backend so we can get it. And then we'll put them together as a prompt, create a variable called suggestion, and then call the replicated model. And again, we can point to the specific model that we are using, and you can get the specific code snip by going to mixtral model page, Python, and copy this code snip in. Except here, I actually changed a little bit, so it will put together the stream result into a final sentence and return to the front end. This is pretty much for the Python code. And in the end, I'll just put this if name equal to main, then we'll run this app, start a server with this specific port. And the last step we need to do is we will need to set the replicate API token. You can just click on copy button here and then go back to the terminal, paste it in and click enter. So this is the whole backend service that we're going to use. Next is we will define this front end. So the front end I have here is actually pretty basic, not very good looking, and I'm sure you can do a lot of improvements. So in the HTML page, we'll firstly define the page title and also CSS styles. And in the main body, I'll firstly create the text input at top so that user can actually type in the specific context about the conversation. And then I'll create a button called record button. Click on which to start the recording. And another button I call summary button. It should actually send the result to replicate mixtral model to get some suggestion back. And also a div to display the generated transcript, as well as another div to display the generated suggestion. After that, we'll define the scripts that we're going to run. I will point to the DOM elements that we defined above, define some state variables. So firstly, I will define what should happen when someone clicks on the get suggestion button. So I will try to get the prompts that users put into the inbox at top, and then I will try to call the backend API endpoint. So you can see here I do await fetch /get suggestion. And this basically means when the button is clicked, it will try to call this function that I define here with the post method as well as the body text by passing on the full transcript. And then in the backend, we'll try to get this to information. Once it's finished, we'll get the result back and display in the suggestion section. So this will basically taking care of the function for get suggestion. Next, which is a part that a bit more complicated, is where we will handle the recording. So I will do the same thing, define when the record button is clicked. If its recording is false, which means hasn't started recorded, then I will trigger the start recording function and change the button text to stop recording. But if the recording already started, then it will trigger the stop recording button and change the button text to start recording. In terms of start recording function, I will use this default library to capture the audio, create a function called create recorder, and define what should be the behavior when we have new data received. So I will capture the audio data and send the audio data back to the function that we define under process audio. And once the result is back, I append the transcript from this new audio chunk to our full transcript variable, and then update the text on the front end. So this is basically a function that we define that will create this recorder, and we'll call this function after to start recording. Here is where we will achieve the behavior where it will try to transcribe every 2 to 3 seconds. So it will basically set interval to some milliseconds, which means every 2 seconds, it will stop the original media recorder and create a new record so that the old audio clip were finished and new audio clip will start every 2 seconds. You can play with this number a little bit if you want. And in the end, I will call this function stop recording to actually stop this interval and a media recorder. So that's pretty much the function. We can open terminal and then run Python app.py. If everything works well, you should see that it's successful running. So you can click on the link and it should show you this interface. Now I will try to play a video clip about someone else having a user interview. So here I will put some context. I'm having a user interview. Above the interview script so far, I'm building an app to help dental clinic to find talents and employees. And you're a world-class UX researcher. Based on information, give me 2 questions I should ask the user to dive deeper. And be sure less than 150 words. So I'll click on this start recording button.
Of finding talent to hire to staff your practice.
Yeah, it's been a journey. In the beginning, you are working on really slim margins, and so you just are grateful to get anybody really who's capable of doing the job. But as time goes on, you really start looking for people who are vested in helping you grow. And so we really try to look for people who are willing to be almost like a partner in this with us. Of course, there's always turnover, but most of our turnover occurs because we have dental assistants who then aspire to be hygienists, and they have bigger goals, and so they move on to those bigger goals rather than turnover because they're dissatisfied with their job.
Right. About how often do you have to replace a dental assistant?
Okay, I'm going to stop here, and you can basically see that it will provide real-time transcript, probably with 1 to 2 seconds delay in terms of the actual audio coming out, and I think that's pretty acceptable range. And at bottom, it will be able to show me some suggested questions that I can ask to actually dive deeper into the conversation. For example, since the user actually mentioned that they want to find an employee not only just can do the work, but more like type of partner. So it's just me to ask, can you describe in more details what do you mean by people who are willing to be like a partner? How do you identify those individuals during the hiring process? So this is a great question because they will directly impact what kind of information we need to surface to help them complete this job. And what's cool about this is you can just totally change this context to be something different. You can even just change the course to be I'm having a job interview for an engineer role. Above is the transcript of interviews so far. Please help me generate questions. So this is also something that you can just change the prompt and start recording the conversation, get real-time suggestions. So this is the first version I did. And to be honest, it actually worked quite well. Even though the UI is very basic, but it definitely gets the job done. But as I just finished off this web application, very quickly, I saw a super impressive project on Twitter called WhisperKit. WhisperKit is an open source fine-tuned whisper model that allows you to deploy the speech-to-text model on your mobile phone directly. And it is small enough that you can even deploy the model on Apple Watch. On the other hand, they also have a demo that is running Whisper model on iPhone 12 and iPhone 15, which obviously has better hardware than the Apple Watch, and showcase some almost real-time, no delay kind of transcript.
All right, it's finally here. This is the Apple Vision Pro. This is the beginning of Apple's spatial computing journey, their first headset, AR, VR, wearable face computer, whatever you want to call it. And this is the unboxing. So everything that I'll show you guys in this box is going to be a representation of what you would get should you decide to spend the $3,500 that it takes to get one of these, or in this case, actually $3,900 because this is the 1 terabyte Vision Pro. You'll see the accessories, you'll see it booted up for the first time, And this is very much the beginning of our Apple Vision.
In this demo, they even put the video on 1.5 speed to showcase capability. If you look closely enough, you can see they actually did a huge amount of optimization to really chunk the audio file in a way that significantly improves the accuracy of the text it returns. And most importantly, this project is open source. So I'm going to try out WhisperKit to build an iPhone or Apple Watch app that can listen to the conversation and get a real-time suggestion about the conversation. This is my first time trying out Xcode. I never built any iOS app before, but it is actually pretty fun. So let's get it. So we'll be using the WhisperKit, which is a Swift package that you can use to develop iOS apps. They'll provide some examples, demonstrate how did they build this real-time transcript app. And we're going to build our iOS-based conversation co-pilot app based on the example apps they provided. So what I'm going to do is clone this GitHub repo, and in the repo, this examples folder. You click on that and then open this WhisperAX folder in Xcode. And if you don't have Xcode, making sure you install Xcode first. In Xcode, you can click on File, Open, and select this folder, click Open. It should automatically load all the package dependencies, where one of them is WhisperKit. In the project folders, there are a few different ones. One is WhisperAX. Another is WhisperAX Watch app. And in terms of other folders, those are just places where you can define the unit tests. So we don't really need to worry about it. And if you open WhisperAX, there's another folder called Views. And inside Content View, SwiftX, this is where the source code are. I'm going to quickly take you through the code here to help you understand how this app is built. But before we need to do some setups. So I will click on this little menu here, select transcript. So this is a package where it will do the speech to text model. And I will click on add a schema. And in the run tab, go to arguments. So here is where we will set something up. Paste in the terminal so you can see it should look something like this. It will be verbose model path. Here is where we define the Whisper model that we're going to download to the local machine. And you should change this path to your computer's path. If you go back to GitHub repo, and there's a folder called models. If you click inside, then you will be able to find the model that you want to use. And the one we're going to use is tiny. So I'll right click, get info, and then copy the path here. And same thing, you're going to replace the audio path to your own file folder as well. And it should be under test folder, WhisperKit tests, resource, and GF. So we're going to do the same thing, get info, copy the path name, and then paste here. So you basically just need to copy paste this into the arguments for transcribe. Once you did that, it should be all good to go. So I will switch this back to WhisperAX project and then play. So this is the example app they provided. Basically, you can choose any model that you're going to use. In our case, we'll select Tiny. And if you click on the load model, it will actually download the Whisper Tiny model to the iPhone device. And I believe for phone model like iPhone 15, you can actually run base model as well, which is a little bit more powerful than tiny model. Then you can select transcribe or stream. So transcribe or basically transcribes the audio file that you store in the test folder. But the one we want is the stream. So streaming basically will allow you to start record audio and streaming out the transcript in real time. However, there are some issues in terms of running microphone in iPhone simulator in Xcode at the moment. So instead of testing here, I will actually switch device to Mac. So I can actually test this whole thing on my MacBook instead. And this is kind of beauty of building iOS app, I found. Basically, you just build once. The same code can be running on a Mac interface, iPhone, iPad. So I will choose the base model and load the model. And once the model is loaded, we can click on the stream menu and start testing it out. So let's try. Click on this. So I want to test out this speech to text model, which is supposed to give me results in almost real time. Okay, so this is working well. And what's really impressive is that the accuracy. So as you can see, it will actually auto-correct the previous sentence if you start getting new audio chunks. And the latency is almost close to zero. So wow, this is really, really impressive. Since the speech to text capability is extremely impressive here, all we need to do is just taking the results, which is transcription here, and then send it to the large language model on Replicate to get suggestion back. So let's do it. And now let's review this code to really understand how this app is structured so we can add our get suggestion button in and also display the result. So the way iOS app works is, so you will define content view, which is the actual app, and then you will define a list of different state. So state, you can consider those kind of global variable that we're going to use. For example, is it actually recording? What is text to be displayed? And which model it is, which tab it has been selected on. So you basically have a list of different variables that you want to define at the top, including things like menu option, which would be transcript and stream. And after that, you will define a function to reset and initialize all the variable state. And then you will define body. So body is where you will define the actual UI. At the beginning, it will add a navigation UI, which is basically the menu on the left side. And inside here, you're basically just putting a bunch of UI components in one after another. It'll put model selector view, which is a customer view that they created, seen at top for people to choose a model. And then add a list of menu. So this is basically referring to the menu here. And you can define the variable to pass on and also a list of behavior. For example, it should be disabled if the model state is not loaded, as well as color, title, and weights. So this is navigation. After that, you will define the detail, which is view on the right side. And if it is running on iPhone, it will be its own separate page. Again, you can just put if condition and define different UI for iOS and Mac OS. Then you will add a toolbar, which is button options on top. So here should be a copy transcription button. And then it will define actual UI. And transcription view is a customer view that you define below here. And it's basically a similar structure. So here is where it will display the result of transcription. For each confirmed segments, we'll try to get a timestamp as well as text. Then use a text UI object to display timestamp plus the actual transcript text. But they are also unconfirmed segments. This basically means there are some sentence is already completed, but there are also kind of half sentence be audio chunk. So the result is not fully complete, which will be in this unconfirmed segments. If you try it out on their UI, you can see that those things at top are those confirmed text, but the things at bottom, like little gray text, are the ones that are not confirmed yet. So this is basically how you display the actual transcription. And then there are more customer view, which we probably don't need to touch. One is the UI to select the model, and also the UI for the controls, which is seen at the bottom. So firstly, we want to define some variables. So I'll move to top and then define one variable called prompt. This is basically a placeholder prompt that we're gonna use in the input box. And then also another state called API response summary. So this is the summary or suggestion result we got from WhisperKit mixtral model. And next, I want to create an input box for people to customize this prompt. So I'll go down to body. Just before the model selection, I'm going to add a text editor that is going to refer to the state prompt, so that user can have a place to put in the prompt. And next, we want to define the function that can cause a mixture model hosted on replica. So I will move down to the logic part. Firstly, I will create one function called getSuggestion. We want to get the full transcript, and the full transcript basically just stitches the confirmed text as well as unconfirmed text together with the timestamp. Then I will create a message to be sent to the large language model. The way to refer variables inside the string in Xcode is you will do slash plus parenthesis to refer to specific variable that you want to insert. So here I will insert the transcript first and then the custom prompt that user put in. And in the end, same body variable that we defined earlier and passing a message as a. Next, we will convert the request data to JSON, create the URL request, which we're referring to the specific model that we're going to use. We'll define the variables when passing a message as a prompt. And next, we're going to convert the request data to JSON, which we will be using a specific mixture model. Then we'll set the request headers to be posts and also passing on the token. So here you will actually need to replace with the API token that you got on WhisperKit website as well as a JSON. After that, we'll actually call the API endpoint, get the results. And one complication here is that the mixture model actually streaming the results here. And to achieve the streaming functionality, after you send the prompt to the API endpoint for the first time, it will return a result to you. Look something like this. Give you an ID, the actual input, the status, and a few URLs. At the beginning, the status will be starting, which means it just started the work. What we need to do is implement a function that will continuously call the get function to get the latest chunk of data until the status became succeed, which means it is finished. And every time we try to call the API endpoint, we will return us an array of text. To handle that, once we get a response, we'll try to get the URL of the get API endpoint. Another function we created called check API result, which will recurrently check the latest status. And here is a check API result function. It will pass in on the API endpoint URL and then define the header. And again, in here, you will need to paste in the WhisperKit API endpoint. And we'll define a variable called isComplete. So at default, it will be false. We will run a for loop until the status became succeed. And then we'll create a variable called isComplete and also create a while loop. So we'll basically wait 5 seconds, and every 5 seconds, we will check the API endpoint again to see is there any new result come in. And if the status is succeed, then we will change isComplete is true, which means the loop will be finished. Otherwise, we will try to get the latest response and then set a state API response summary to be the latest summary that we got. So that's pretty much it. All we need to do now, just display this text on the screen. I will move to top, and right after the UI components, we are displaying the actual transcription. I will add this text block. So if the API response summary actually exists, then I will insert a text display with the value, which is the API response summary, which should be the suggestion that we return from mixtral model. The last step we need to do is just adding a button for get suggestions. I'm going to move down here. After Control View, I want to add a get suggestion button. So I will add a button, get suggestion, and trigger this get suggestion function. Okay, now we can try to run this conversation copilot on our iPhone directly. If it is your first time set up Xcode project as well, you need to click on Window, Device and Simulators, making sure your phone is connected here. And you also need to set up a developer mode. So you need to go to Settings, Privacy and Security. At the bottom here is a developer mode, so you need to turn it on. Once that part is done, you can select the device here to be your iPhone and click play button. Inside the VPN and device management, it will ask you to trust the developer first so that you can install the app. Okay, so you can see the app is loading. We can select different models. I think base is the best model for iPhone at the moment. And I click on load model. The first time it will take a little bit of time to actually download this Whisper model to the iPhone, but after that it should be much quicker. And I can edit the prompt here as well to give large language model more context about the conversation. Once it's done, I'll click on stream and I'll just play the same user interview clip I did before.
Your experience and your process of finding talent to hire to staff your practice.
Yeah, it's been a journey. In the beginning, you are working on really slim margins, and so you just are grateful to get anybody really who's capable of doing the job. But as time goes on, you really start looking for people who are vested in helping you grow. And so we really try to look for people who are willing to be almost like a partner in this with us. Of course, there's always turnover, but most of our turnover occurs because we have dental assistants who then aspire to be hygienists, and they have bigger goals, and so they move on to those bigger goals rather than turnover because they're dissatisfied with their job.
So this is a quick demo of our real-time conversation copilot iPhone app. It's actually really impressive. As you can see, the transcription also happened in real time with very, very little latency. And the time for mixtral on replicate to generate suggestion is almost instantly as well. So overall, I think it really unlocked a new set of real-time use case that wasn't possible before. I'm actually planning to polish this real-time conversation app a bit more and publish as a proper iPhone app. So please comment below if you're interested. I will let you know once it is out. I will continue posting interesting AI projects I've been doing every week. So feel free to like and subscribe if you want to keep updated. Thank you, and I see you next time.